ground fault circuit interrupter, or GFCI, will not function correctly nor protect the entire circuit if the line and load neutrals are twisted together. A GFCI receptacle requires both the line and load terminals to be used correctly for proper functionality. The line terminals are connected to the incoming power, while the load terminals are connected to the downstream devices on the circuit. If the line and load neutrals are twisted together and connected to the line side of the GFCI, this creates a parallel path for the neutral current. As a result of this improper wiring, the GFCI will not be able to detect any imbalances between the line and load currents. Detecting imbalances between the line and load currents is the GFCI's primary function for detecting ground faults. To ensure proper operation and protection from potential ground faults, the line and load wires must be connected to their respective terminals on the GFCI receptacle. The neutral wires should be connected to the neutral terminals on both the line and load sides, and the ground wires should be connected to the ground terminal. Firstly, identify the line and load terminals on the GFCI receptacle. The line terminals are for the incoming power, while the load terminals are for the wires that continue the circuit downstream. Secondly, connect the incoming hot wire, which is typically black, to the line hot terminal on the GFCI. Thirdly, connect the incoming neutral wire, which is typically white, to the line neutral terminal on the GFCI. Fourthly, connect the outgoing hot wire to the load hot terminal on the GFCI. Fifthly, connect the outgoing neutral wire to the load neutral terminal on the GFCI. Sixthly, connect the ground wire to the ground terminal on the GFCI. Ensure that all connections are secure and properly tightened. Lastly, after wiring the GFCI receptacle, it is crucial to test it to ensure that it is functioning correctly. The GFCI receptacle has a test and reset button on its face. The test button simulates a ground fault to verify that the GFCI trips and interrupts the circuit. Press the test button to simulate a ground fault. The GFCI should trip, cutting off power to the circuit. If the GFCI does not trip when the test button is pressed, there is a problem with the wiring or the GFCI itself. After the GFCI trips, press the reset button to restore power to the circuit. If the GFCI trips immediately after resetting, it indicates a persistent ground fault condition that needs to be addressed. When troubleshooting a GFCI, it is important to follow certain safety precautions. Firstly, always turn off the power to the circuit at the breaker before working on any electrical connections. Secondly, use a non-contact voltage tester to verify that the power is off before touching any wires. Thirdly, never bypass a GFCI or tamper with its internal components. Fourthly, if you are unsure about any aspect of the wiring process, consult a qualified electrician. In a standard electrical circuit, current flows from the power source through the hot wire to the load and back to the power source through the neutral wire. A ground fault occurs when the current deviates from its intended path and flows through an unintended path to ground, such as through a person touching a live wire. A GFCI constantly monitors the current flowing through the hot and neutral wires. In a properly functioning circuit, the current flowing through the hot wire should be equal to the current flowing through the neutral wire. If the GFCI detects a difference of as little as 5 mA between the hot and neutral wires, it assumes that a ground fault is occurring. When a ground fault is detected, the GFCI trips, interrupting the circuit and cutting off power to prevent electrical shock. Ground fault circuit interrupters are designed to protect people from electrical shock by detecting ground faults and quickly interrupting the circuit. GFCIs are commonly installed in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. There are two main types of GFCIs: receptacle type GFCIs and circuit breaker type GFCIs. Receptacle type GFCIs are installed in place of standard electrical outlets, providing protection at the point of use. Circuit breaker type GFCIs are installed in the electrical panel, providing protection for the entire circuit. When selecting a GFCI, it is important to choose one that is rated for the appropriate voltage and amperage. GFCIs are typically rated for 120 volts or 240 volts and 15 amps or 20 amps. It is also important to choose a GFCI that is listed by a recognized testing laboratory, such as Underwriters Laboratories, or all to ensure that it meets safety standards. When installing a GFCI in a bathroom, it should be located at least 6 feet away from the edge of the sink or shower. This helps to prevent water from splashing on the GFCI and causing it to trip. When installing a GFCI outdoors, it should be protected from the weather by a weatherproof cover. This helps to prevent water and other elements from damaging the GFCI and causing it to malfunction. If a GFCI trips frequently, it may indicate a problem with the wiring or an appliance connected to the circuit. In this case, it is important to troubleshoot the circuit to identify and correct the source of the problem. Firstly, check all of the outlets and appliances in the circuit for any signs of damage or loose connections. Secondly, test each appliance individually to see if one of them is causing the GFCI to trip. Thirdly, if you are unable to identify the source of the problem, consult a qualified electrician. GFCIs are an essential safety device that can help to protect people from electrical shock. By understanding how GFCIs work and how to install them properly, you can help to ensure the safety of your home or workplace. It is always important to prioritize electrical safety and follow all applicable codes and regulations. If you are unsure about any aspect of electrical work, consult a qualified electrician. The National Electrical Code, also known as NEC, provides comprehensive guidelines for electrical installations, including the use of GFCIs. The NEC requires GFCIs in various locations to enhance electrical safety. The NEC is updated every 3 years to incorporate the latest advancements in electrical technology and safety practices. It is important to stay up to date with the latest edition of the NEC to ensure compliance with current regulations. Understanding basic electrical concepts such as voltage, current, and resistance is helpful when working with GFCIs and other electrical devices. Voltage is the electrical potential difference between 2 points measured in volts. Current is the flow of electrical charge measured in amps. Resistance is the opposition to the flow of current measured in ohms. Ohm's law states that voltage is equal to current multiplied by resistance, or volts equals amps times ohms. This relationship is fundamental to understanding how electrical circuits work. Grounding is an important safety measure that helps to prevent electrical shock. Grounding provides a low resistance path for fault current to flow back to the source, causing the circuit breaker to trip and energize the circuit. The grounding system consists of a grounding electrode, such as a ground rod or metal water pipe, connected to the electrical panel and all metal enclosures. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. Bonding helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD divert the excess voltage to ground, preventing it from damaging sensitive electronic components. Arc fault circuit interrupters, also known as FSIs, are designed to protect against fires caused by arc faults. Arc faults occur when electricity jumps between two conductors, creating a high-temperature arc that can ignite nearby materials. FSIs detect arc faults and quickly interrupt the circuit, preventing a fire from starting. Electrical safety is a shared responsibility. By following safe practices and using appropriate safety devices, everyone can help to prevent electrical accidents. If you are not comfortable working with electricity, consult a qualified electrician. Remember to always turn off the power at the breaker before working on any electrical circuits or devices. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical equipment in wet or damp conditions. If you see any signs of electrical hazards, such as frayed wires or sparking outlets, report them immediately. By following these safety tips, you can help to protect yourself and others from electrical hazards. GFCIs are just one part of a comprehensive electrical safety plan. It is important to consider all aspects of electrical safety to ensure a safe environment.